Okay, so this is the review session for EGME 401, fall 2022, midterm 1. Okay, so I graded a lot of your homeworks, and just like I mentioned in the emails, it seems like a lot of people are still struggling with the non-standard cash flow conversions. And so, normally for these reviews, I try to tackle kind of more than one topic, but just kind of from what I've seen from your homework, seems like everything else in the class seems to be kind of sticking really well. It's kind of just the non-standard cash flow conversion, which is pretty normal, actually. I'd say for for this course, this is definitely the topic that people struggle with the most. And so I'm gonna go ahead and review this by doing the 3 homework problems from the last homework here for you worked out, so you can kind of see my thought process kind of step by step. Because with these kinds of problems, it really helps to kind of see it. More examples so that you have a good thing to reference to when you're studying. Okay, and so let's just kind of quickly review what I mean by non-standard cash flow conversions. Okay, and so these are basically any time that you need to convert between 2 different forms of cash flow, but they're not in the standard form. Okay, so hence the name. And so the reason they're called non-standard cash flow conversions is that most of the time you can't convert the cash flows in just a single step. And so you're going to have to do multiple steps, multiple conversions multiplied by each other in order to get the conversion that you want. Okay. And so before we jump into a homework problem, let me do just a quick example. Okay. And so let's say that we have a cash flow diagram looks like this. Okay. So you have 0, 1, 2, 3, 4, 5, 6. Okay. And let's say that we have a uniform series that's occurring on the last 4 years of this cash flow diagram. So we have one up like that, one up like that, one up like that, one up like that. Okay. And so we have these 4 cash flows, and they all have the same value. And so let's say they all have a value A. Okay. And we want to convert this to the equivalent lump sum on year 0, or in other words, the present sum. Okay. Okay. And so a lot of people might look at this and think kind of one or two things. And so one way they might think of this is that, okay, this cash flow diagram goes up to 6 years. And so one way that we can convert this is we take A, P over A, right? Because that's the type of conversion that we want. We want to take an A, convert it to a P, right? Let's say the interest rate is given to you. It's not really that important here, okay? And we see that, the last year in this here is year 6, right? And so one might think that you might put a 6 right here, okay? Because the uniform series ends on year 6, and so some might think that that might be the way to convert this. Or another way that people might think is to say that we can see that this uniform series only occurs 4 times, right? And so it only it only repeats itself 4 times. And so another way that people might do it is something like this, okay? But they put 4 in for the n, and then call it a day, okay? And so unfortunately, both of these are actually wrong, okay? Because right now, this uniform series is not in standard form. And so this uniform series, doesn't start on year one. And so if this were a standard form uniform series, it would start on year one right here. But it doesn't. It starts on year three. Okay. And so we're going to have to do this in multiple steps. Okay. And so the first step of this actually is going to be something like this, is to convert this uniform series into a single sum. Okay. And so if we do A, P over A, I, and 4, okay, that's going to take this uniform series and condense it down into a single lump sum, but it's not going to be in the location that we want. And so after doing this conversion, we have right, let me draw our cash flow diagram again. Okay. And so by doing this conversion right here, A, P over A, I, and 4, we've condensed this, this uniform series right here for 4 years into a single lump sum. And that single lump sum is going to be a p-value, right? But, because this starts on year 3, that p-value is going to be placed on the year immediately preceding that, right? Because that's the standard form for uniform series. And so for uniform series, we're used to it starting on year 1. And so if you convert that uniform series starting on year 1 into a presence day sum, then it's going to put it on the year before that, okay? And so in this particular case, the year before this starts is actually going to be on year 2, okay? And so after we perform that conversion, we end up with this. And so the value for this lump sum right here is going to be A, P over A, I, and 4, okay? And so, of course, I think everyone knows by now that when you, when you perform this conversion, you would look up this number in the compound interest tables, and then you would multiply by A, and you get a new number, okay? And so this entire quantity here, this A times P over A, I of 4, this is something that you can compute. And so this right here is just a number, right? But we're not quite done yet. And so remember, our goal here was to convert this to a single sum on year 0, okay? And so we're going to need to take this and move it back in time 2 years from there, okay? But luckily, we know how to do that because now, our cash flow here is just in a single lump sum. And so to perform this conversion, we take this and we multiply it by P over F, I, and 2, okay? And so now that that transforms our cash flow diagram okay. And so that transforms our cash flow diagram into a single lump sum here on year 0, okay? And the value for this is going to be all the conversions we've done so far multiplied by each other, okay? And so we have A, P over A, I, and 4, okay? And then we're going to multiply by our second conversion here, which is P over F, I, and 2, okay? And so our total conversion here is going to be A, P over A, I, 4, and then we multiply by our second one, P over F, I, and 2, okay? Excuse me. Okay, I'm back. All right, and so that's how we would do this, the simple kind of non-standard conversion, right? And so, just to kind of recap where we were, we had this uniform series here. It doesn't go, it's not standard form, right? If it was standard form, it would start on year 1 and go all the way to year 6. And so to convert this to present day form, we had to do this in 2 steps. And first thing we did was we kind of lumped it all into 1. And so we did a P over A, I 4, right? But because this uniform series started late, it placed that uniform series kind of in the year immediately preceding or immediately before it started, so on year 2. Okay. From there, we just did a simple P over F conversion where we took the single sum and moved it back in the past 2 years. So that was a P over F I n 2. Okay. All right, so let's go ahead and let's jump into the homework problems. Okay, so I'm going to be reviewing all 3 parts to problem 3 on homework 2. Okay. Okay, so let's start with 3A. Okay, and so in this problem, what it says is that a crane was recently purchased by a construction company to assist with some of its construction work. Okay. And this crane comes with the protection plan. And so the point of the protection plan is that there's be no maintenance costs, for the first 4 years. Okay. But despite that, the company plans on using the crane for another 12 years. And so, it wants to set aside money now to pay for all the repairs once the protection plan expires. Okay. Okay. All right, so the first thing we're going to do here, before I get into the costs, let's go ahead and draw the cash flow diagram. And this one thing I noticed a lot too, that not a lot of people are drawing cash flow diagrams, and so I know it's a pain. I know it takes up a lot of space, but trust me, it is really helpful to draw these cash flow diagrams, because as you can see, kind of in our first kind of very simple example. Drawing the cash flow diagrams can let us visualize, how each of the different conversions, how that transform our cash flows. Okay, because without it, especially if you haven't been doing these a lot, it can be hard to visualize, what's really going on. Okay, so I'm gonna go draw my cash flow diagram, and so I know that we're gonna need it for 12 years. Okay. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And so the problem states that that the first 4 years are going to be covered. And so we're going to have no cash flows in the first 4 years. Okay. Starting in year 5, that's when we're going to start to have some costs. Okay. And so what the problem says is that repair costs are going to be $18,000 per year in the 5th and 6th years. Okay, so this is going to be $18,000. Okay. The repair costs are going to increase to $21,000 per year in year 7 through 10. Okay. Okay, so all of these are going to be $21,000. And then finally, in the 11th and 12th years, we have a repair cost of $24,000 per year. Okay. I'm going to draw 2 arrows here. This is going to be $24,000. Okay. Okay. And so if we're assuming an interest rate of 5%, okay, we want to compute, how much money the company should set aside now, okay, in year 0 to pay for all these repairs in the future. Okay, so we're basically doing the exact same thing as our simple example. So we're converting all of our cash flows here into a single equivalent, present sum. Okay, so let's start working on this. All right, and so if you kind of look at this problem, you look at the cash flow diagram here, you can see here that we have basically three uniform series that we need to worry about, and they all need to be converted back to year zero. Okay, and so if you read the homework solutions, which by the time this video airs is going to be up on Canvas, you'll see me kind of approach this in a slightly different way. But just for kind of the sake of consistency for this video, I'm going to repeat the same process that I went through up here just 3 times, just so that you can see it. Okay, and so I'm gonna do that process first for these two right here. Okay, then I'm gonna do it for this set. Then I'm gonna do it for this set. Okay, and so I'm gonna treat these as three separate uniform series. Okay, so one mistake I saw quite a bit in the homeworks is that some people try to work in some arithmetic gradients into this problem, which is not a bad idea. And so, we've learned about arithmetic gradients as, ways it's basically a cash flow that increases with time. And this is something that the costs here are going to be increasing with time. But if you notice here that the increases year to year are not consistent here, right? And so in years 5 and 6, the cost, there's going to be no cost increase. And so the increase is 0. But from 6 to 7, the increase is $3,000. But again, we have a period where there's no increase, and then 10 and 11, we have an increase of 3,000. So you should only use an arithmetic gradient when you have a constant increase year after year after year after year. Okay. Okay. And so we don't have that here. And so, we have what we have instead are kind of 3 separate uniform series. Okay. And so let's kind of work on each of these series kind of one by one. And so let's start from on the $18,000 series. And so that's on years 5 and 6. Okay. Okay. And so this is a uniform series that occurs over two years. Okay. So the first thing we're going to do is we're going to convert this into a single lump sum. Okay. All right. So the first thing we're going to do is we're going to do 18,000. Okay. We're going to convert this into a single lump sum, and so we're going to do P over A. Okay. Our interest rate here is 5%. And the number of times that this is occurring is 2 years. Okay. Okay, and so let me go ahead and look this up because I actually haven't done it this way, but I'm doing it live. Well, live for me, but it'll be whatever time that you view it at. Okay. All right, so let's go to the compound interest table for I is equal to 5%. Lots of scrolling. Okay, 5%. And so what we want is P over A. So P over A is this column right here, and we want I is equal, or N is equal to 2. Okay. And so from the compound interest tables, we see that this conversion factor here is 1.859. Okay. And so if we perform this arithmetic, we have 18,000 times 1.859. And what we get from this is 33,462. Okay. And so now we've converted this this uniform series here into a single lump sum. Okay. But remember that the single lump sum is not on year 0 yet, right? And so if you go back to our example up here, we've converted this uniform series into a single lump sum that's located on the year right before, right before this started. Okay. And so if we're considering this for 18,000, our single lump sum here is actually occurring on year 4. Okay. And so if I were to kind of draw this in, okay, let me go ahead and erase these. Okay. And so we've gone ahead and converted that $18,000 on years 5 and 6. And so now we have a single lump sum of $33,462. Okay. And that's occurring on year 4 because that's the year right before that series took place. Okay. And so, of course, we're not done yet. And so what we want is a single lump sum on year 0. And so we need to transport this back in time by 4 years. Okay. And so we're going to take this 33,462. Okay. And we're going to multiply it by another conversion factor. That's P over F, 5%. And in this case, we're starting in year 4 and we're taking it back to year 0. And so that's 4 years into the past. Okay. And so once again, we're going to look this up in the table. So we have P over F, I is equal to 5 and 4. And so this here is a 0.8227. Okay. And so we perform that arithmetic there and we get 33,462 times 0.8227. Okay. And what we get from this is 27,529.19. Okay. And so another way that we can obtain this is we can start with kind of our original expression here and multiply our second conversion. Okay. Okay. And so we started with 18,000. First thing we did was P over A, 5% 2. Okay. And then we're going to add our second conversion factor here, which we added in the second step. So this is going to be P over F, 5% and 4. Okay. We can plug in for these. And so this is 1.859, 0.8227. Okay. And if you perform this arithmetic, one after the other, what you should get is 27,529.19. Okay. Okay. And so that's just, it's an example of the example that we did earlier. Right. So let's go ahead and repeat this 2 more times. Okay, so let me go ahead and erase this because we've already converted it. Okay. I'm telling you guys, use the cash flow diagram. It's useful, and so they're especially the next problem that we're going to do, where it's really hard to keep track of it without the cash flow diagram. Okay. Okay. So next we have this $21,000 series. Okay. Okay. And so just like we did with the $18,000 series, we're going to convert this into a single lump sum. Okay. And so I'm going to start with 21,000. Okay. I'm going to do this a little bit differently, though, just to kind of show you that there are kind of multiple ways that you can do a non-standard conversion. Okay. And so what we did before was we took this uniform series, we transformed it into a P, which occurred, 1 year before, the the series took place. And so this is a P over A conversion. Okay. So that's what we just did. But another way that we can clump this together is that we can perform an F over A conversion. Okay. And so instead, let's take this and let's convert it into a single lump sum on year 10 with an F over A. Okay. Because remember, the standard form or the standard conversion between F and A is that if you convert a uniform series to a future sum, that future sum is going to occur on the very last year or the very last period where that uniform series is taking place. Okay. Okay, so let's go and do that. So we have 21,000. We have an F over A conversion. Our I here is 5%. And the number of years this is taking place is 4. Okay. Okay, so let's go ahead and look in the compound interest tables, and we have F over A. The F over A for 5% and 4. This is 4.310. So we'll punch that into the calculator. 21,000 times 4.31. Okay, and we end up with 90,510. Okay, and so let me go ahead and update the cash flow diagram here. Okay, go ahead and erase all this. Okay, so now we're going to have a single lump sum on year 10, and its value is 90,510. Okay, so we've consolidated the series into a single lump sum on year 10. But remember, our goal here is to put this back on year 0. And so what we're going to do is I'm going to transform this back with a P over F conversion. Okay. Okay, so let's take that 90,510. Okay. We're going to convert this back to present day. So P over F, 5%. And the number of years we need to transport it back is 10 years. And so our N here is going to be 10. Okay. All right, so let's go ahead and look this up. So we have P over F, 5% and 10. And so from the compound interest tables, this is 0.63, or excuse me, 6.139. Okay. So let's go ahead and punch that in. So we have 90,510 times 0.6139. And we get 55,564.09. Okay. This is 55,564.09. Okay. All right, and so we've done basically the same things before. It's just that we took a little bit of a different path to get there. Okay, and so finally we have the last series here, which is 24,000. And so we have the $24,000 series. Okay, and so just like the first two, first thing we're going to do is convert this into a single lump sum. Okay. And so you can kind of choose how you want to do this. And so you can either do this, with a P over A, or you can do F over A, it doesn't really matter. And so let me go back to the first way. And so just because we've already looked up the P over F for 10, okay. And so let me do this as P over A, 5. And the series is going on for 2 years. And so that's all we need. So P over A, 5% and 2 is 1.859. Okay. So if we do 24,000, one extra 0, times 1.859, we get 44,616. Okay. So let me come back up here. Go ahead and delete all this. Okay. Delete this for a second too. Okay. Let's go ahead and use orange. Okay. And so after doing that one conversion of converting the uniform series on years 11 and 12, we get a single lump sum here of 44,616. Okay. And then just like we did in the previous one, now we have a single lump sum in year 10. Now we need to take it back to year 0 with a P over F. Okay. All right. And so we have 44,616 P over F, 5%, 10. And we know from up here that this conversion factor here is 0.6139. Okay. So let's go ahead and multiply by that. So we have 44,616 times 0.6139. And so what we get from this is 27,000 389.76. Okay. All right, so now what we can do is we can add all these together. And so we have a 27,529, 55,564, and 27,389. And so I'm gonna go ahead and add all those three up. Okay. So total present day cost. Okay. So we have 27,529. Okay, so that's from the first series from years 4 and 5. Then we have 55,564.09. Okay, so this is 4 to 5, and this is or excuse me, 5 and 6. Okay, this is year 7 through 10. And finally, we have years 11 through 12. 27,389.76. Okay, so if we go ahead and add all this together, it's going to give me a second to do so. So you have 27,529.9 plus 55564.09 plus 27,389.76. Okay, what we get from this is 110,000. 483.04. Okay. All right. And so if you compare this to what the answer that's in the homework assignment, it is a bit off just because, the path that I took to get here was quite different. But it is very close. And so, I've gotten a lot of questions from people about, how close do you have to be? Is there some rounding error? So like, yes. And so, yes, there is going to be some rounding errors depending on the path and depending on, your calculator and what conversion factor you use. And so it might be off a little bit, but, for the most part, it's going to be satisfied. Okay. Okay. And so hopefully that problem there kind of illustrates to you, how we do the non-standard conversions. Actually, let me do one more thing before we move on. And so just to kind of summarize it, let me kind of show you the path that we took to get here. Okay. So we had 3 uniform series. Okay, and we did a non-standard conversion on all 3 of them. Okay, so let me go ahead and summarize it for you. And so another way that we can do this, or not another way, but just another way we can format it, is to kind of list out all the conversions in a single formula. Okay, and so the first conversion that we did was we did 18,000 times P over A, 5% and 2. Okay. And then we did another conversion here, which we converted this with the P over F. So this is P over F. P over F, 5% of 4. Okay. Next, we have the $21,000, and so that's $21,000 times F over A. 5%. 4. Okay. And then we multiply it by P over F, 5% and 10. Okay. Then to that, we added the last series, $24,000. And then first thing we did was P over A, 5% and 2. And then we did P over F, 5% and 10. Okay. If we add all this together, we plug in all the conversion factors. What we should get is our number just like that. Okay. Okay. And so that's the entire answer in one singular form, right? And so, I know it's tempting to kind of jump to something like this, but it is really important and really useful for you to draw out the full cash flow diagram so that you can kind of see and visualize, what your conversions are doing. Otherwise it's kind of easy to get lost. Okay, let's go ahead and move on to the next problem. And so we have problem 3B. Okay, let me just go ahead and zoom in just so we can see a bit better. Okay, and so this is, you know, I think a lot of people think of this as kind of the hardest, one of the hardest problems from this first unit. Okay, and that's kind of year after year. Okay, so the idea behind this problem is that you know, some parents want to save money for their daughter's college education. Okay. Okay. And so the cash flow diagram for this is actually going to be really, really massive because, you know, we're talking about from birth all the way until she's you know, 21 years old. Okay. And so even though this problem doesn't say to do it explicitly, you know, again, you know, I always think it's really useful to draw the cash flow diagrams, you know, as much of a hassle as it can be. Okay. And for this one, it's particularly a hassle because we have 21 years. Okay? Okay. All right. So you know, it's a little bit soon. Drew the dots a little bit closer than I thought, but that's okay. Okay, so let's go ahead and label these. And so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12. Okay. All right, so let's start filling this in. And so the first thing we have is that we have a gift from grandma and grandpa. And so gift from the grandparents is an initial deposit of $1,000. Okay. Okay, so that's money that the family is receiving, right? And what we also know is that tuition costs in years 18, 19, 20, and 21 are going to be $25,000 a year. Okay. Okay. All right, and so what next thing the problem says is that starting in year 4 and going on for 4 years, the parents are going to be able to invest $1,500 a year. Okay. And so years 4, 5, 6, and 7. Okay, this is all going to be $1,500 a year. Okay. And starting in year 9, they're going to be able to increase their investment amounts by a flat amount each year. Okay. And so, you know, this wording can be a little bit confusing. And so basically what that is saying is that, you know, starting in year, oh, sorry, we have one more. Okay, oops, wrong blue. Okay. And then year 9, yeah, like that. Okay. Okay. And so starting in year 9, you know, they're going to be able to increase their amounts by a flat amount each year. Okay. And so the way to kind of interpret this is that, you know, each year, you know, the amount that's going to be increasing is a gradient. Okay. So let me go ahead and add this flat amount. Okay. And so this is going to continue until, you know, year 17, right? And so even though we're increasing our amounts, you know, our flat amount is still going to be there. Okay. And so we have this $1,500 each year, okay, from years 4 until 17. And then on top of that, we're going to be increasing that amount starting in year 9. Okay. Okay. And so the cash flow diagram is going to look like that, where this amount is going to be the amount that we solve for. And so this is going to be, you know, G. Right. Okay, and so the point, and so the goal for this problem is to solve for this G right here. Okay, assuming that our interest rate for this problem is going to be 7%. Okay. All right, so there's a lot going on in that problem, but it's good to draw it out. Okay, and I believe it looks like in the homework solutions I didn't post that, or I didn't post the cash flow diagram, and so this is kind of good to kind of visualize, to act as an aid. Okay. All right, and so in these kinds of problems, where you're kind of solving for an unknown amount or unknown cash flow within the cash flow diagram, this is a type of problem what we call balancing the cash flow diagram. Okay, I might have called it something different in the class, but that's essentially what we're going to do. Okay, and by balance the cash flow diagram, that all that means is that we put all the benefits on one side, all the costs on the other. Okay, we set them equal to each other, and that's what it means. So by balance means that all costs equal all benefits. Okay. But remember, when we're talking about cash flows that occur over many years, we have to do conversions in order to make equality. Okay, and so we have to set all costs equal to all benefits. Granted, we perform the needed cash flow conversions so that all of these cash flows are in the same form. Okay. 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 And so, what we're going to do is we're going to take all of the costs, okay, convert it into a standard cash flow form. And we're going to do the same thing with the benefits, set them equal to each other, and then we'll have our equations to solve for G. Okay. And so you have a choice here. And so, you can choose, what form of cash flow you want to convert to. Usually for me, I like to convert it to a present sum because that's kind of the simplest to do. Okay. Okay. All right, so let's start with the cost. And so we only have one cost here. And so it's a uniform series on years 18, 19, 21, 20, 18, 19, 20, 21. Okay. And those costs are meant to represent tuition. Okay. And so what we have here is a situation that is basically identical to the one that we had in the previous problem. Okay. So we're going to follow the exact same recipe. Okay. And so we have a $25,000 series. Okay. It's non-standard because it's only occurring at the very end, and we want to convert this into a single lump sum on year 0. Okay. All right, so let's go ahead and perform our conversions. And so, we have a couple ways that we can do this. First thing we want to do is we want to lump this all together into one sum. Okay. And so first thing I'm going to do is I'm going to convert this into a P over A. Okay. Interest rate here 7%. And this uniform series occurred over 4 years. Okay. All right. And so just like before, this is going to lump all this together. And so let me go ahead and delete all of this. Okay. And so instead of that uniform series on years 18, 19, 20, 21, what we're going to have instead now is just a single lump sum here. Okay. And so that value, let me go ahead and jump to the compound interest tables. Okay. that value there, P over A of 7% for this right here is 3.387. Okay. So let's go ahead and punch that into the calculator. So we have 25,000 times 3.387. Okay. This is 84,675. Okay. Okay. And then what we're going to do from here is then transport it back into year 0. So this is going to be a P over F conversion. Okay. And so we have 84,675 times P over F, 7%. Right. Remember that when we perform P over A, it puts that single lump sum on the year before the series started. So since the series started on year 18, and we lump it all together into a P over A, that's going to be on year 17. Okay. And so now we need to transport this this 84,000 back in time 17 years. Okay. Okay. So let's go ahead and jump to the table. P over F, n is equal to 17. This right here is 0.3166. Okay. And so we go ahead and punch that into the calculator. So 84,675 times 0.3166. And what we get is 26,808.11. Okay. And so that right there is the present day value of all the costs. Okay. And so now we're going to do the same thing with all the benefits and set them equal to each other. Okay. Okay, so we have several benefits here. So we have 3 in total. Okay. First thing we have is the $1,000 initial investment from grandma and grandpa. Okay. And so for this $1,000, we actually don't have to do anything. And so this is already in present day format. And so we can just keep it as such. Okay. Next, we have this $15,000 that the family started when the girl was 4 years old. And then this continued up until year 17. Okay. Okay. And so first thing we're going to do, this is exactly the same as before, is we're going to convert this into a lump sum. Okay. All right, so we have P over A, 7%. And now we need to count how many years that this took place. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 years. Okay. So we have 1,500, P over A, 14. And so we go into the tables, P over A, 14. This is 8.745. Okay. So we have 1,500 times 8.745. This is going to be 13,117.5. Okay. Okay, but we're not done yet. And so, we need to convert this back into present day. Okay. And so since this, since this is a P over A, it's going to put it on the year that it before it started. So that's going to be year 3. Okay. So we have 13,117.5. Then we have P over F, 7%, 3. Okay. And so we have, we go ahead and look this up. P over F, 7%, 3. This is 0.8163. Okay. And so this is 10,707.82. Okay. And so those are the two, those are the two, excuse me. So those are the two, benefits that we have so far. Okay. All right. And so the last one that we have is the increase. And of course, that's what we're solving for here. And so all we need to do here is set up the equation for it, plug in the conversion factors, and then solve for it. Okay. And so this is going to be for the increase G. Okay. And so even though we don't know the value of G, we at least have the structure of G here for us. Okay. And so, we know that G starts on year 9. Okay. And then it continues on until year 17. Okay. And so, first of all, we need to count how many years that this gradient is going to take place. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And so the increase, it occurs 9 times. Okay. Okay. And so let's go ahead and start setting up the equation. And so we have G. And so first thing I'm going to do here is, our only, our only mechanism for converting from G is a P over G. We have A over G as well, but A over G is not as useful. Okay. Our interest rate here is 7%. Okay. And now we need to put N for this. Okay. But remember, we have to be careful here because the gradient is actually quite special, because the N that you put for the gradient is not the number of times that you see it occurring. It's the number of times you see it occurring plus 1. Okay. Okay. And remember that plus 1 is due to the fact, or due to the, the reason is because we assume that this only represents an increase. And so if we look at the standard form for G, okay. Remember, the only time you start seeing increases for G is actually on year 2. Okay. This increases G. But, we still count year 1 right here, because year 1 is like we have a 0 G. Okay. And so this would be a gradient that occurs over 6 years. Okay. Even though we only see increases for 5. And so that's why this P over G here is a 10 and not a 9. And so, that one's tricky right there. Okay. Okay. And, the next tricky thing is, where do we actually put this, where do we actually put this gradient as well? And so since, we're converting this to a P, we actually put this 2 years before the increases start occurring. So this is actually going to occur on year 7. Okay, well, it should be pointing up, not down. Okay. And then so, if this conversion right here creates a lump sum on year 7, okay. Because remember, the lump sum that we create for this is going to be 2 years before the increases actually start happening. Okay. And so to convert this back to present day, what we need is actually a P over F conversion for this. Okay. A P over F conversion that is listed for 7 years. Okay. And so before we do that, we can go ahead and plug in for this. And so this P over G factor, 7% and 10. Let's go ahead and look this up. P over G, 7%, 10. This is 27.716. Okay. Yes, we have 27.716 times G. Okay. Then we need to multiply this by P over F, 7% and 7. Okay. All right. And so this conversion factor right here is 0.6227. Okay. And so if we multiply these two together, we have 27.716 times 0.6227. This gives us 17.9 17.26 G. Okay. So now that we've converted all the cash flows into present sum format, we can go ahead and put them all together. Okay. And so on one side, we're going to have all the costs. On the other side, we're going to have all the benefits. Okay. And so the cost, we only had one. So our cost is going to be $26,808.11. Okay. And on the benefit side, we have $1,000. That was the initial investment by grandma and grandpa. Then we have the $1,500 series. And so that's going to be $10,707.82. Okay. And then finally, we have the contribution from the increase. So that's 17.26 G. Okay. All right. So it was a long time coming, but now we can go ahead and solve this for G. Okay. So I'm going to go ahead and subtract everything from this side. Okay. So I'm going to subtract that over here. So 26,808.11 minus 1,000 minus 10707.82. Okay. And so this right here is 15,100.29. This is equal to 17.26 G. Okay. Now I'm going to divide that by 17.26. Right, and what we get from this is that G is equal to $874.87. Right, so if we compare that to the answer that's given, we're only off by about 7 cents. Okay, so remember, there's always going to be a little bit of round off error, so don't stress it if you don't meet it exactly, but as long as you're pretty close. Okay, and so this actually went on for actually quite a bit longer than I thought, and so I'm going to go ahead and end it pretty soon. So 3C is actually a lot simpler than this, and so if you understand A and B here, then C is pretty easy. But I do want to show you this equation here, and so we kind of did part B here in kind of several different steps, but you can actually kind of form the entire equation in one step right here. Okay, and so all it really consists of is basically doing your non-standard conversions kind of one after the other and all into one. Okay, and I want to do this because I want to show you kind of how the non-standard conversions actually are. Okay, and I think this is actually what's listed in the homework solutions as well. So okay, so we have costs and benefits here. All right, so remember our cost was $25,000 a year. First thing we did was a P over A, 7% and 4. Okay, that was a P over F, 7% and 17. Okay, so those are our non-standard conversions for the cost. Okay, so you can see that we did 2 conversions here. Okay, now we have the benefits, and so on the benefit side we have 1,000. Okay. So that's the same as before, and so there's no converting on that one. Okay, then we had 1,500. This was a non-standard conversion, so this is P over A, 7%, 14. Okay, then we have another conversion here as we move this back to present day. So this is P over F, 7% and 3. Okay, and then finally we have G. So we have G, P over G, 7%, 10. Then we move this back to present day, so we have P over F, 7% and 7. Okay. Okay. And so this right here is exactly the same as you had above. It's just I put all the conversions in one place so you can see, how each of these are converted. Okay. And so remember, whenever you have a non-standard cash flow conversion, you're probably going to have to do at least 2 conversions. Usually not more than 2, but 2 is at least. Okay. All right, and so that that took longer than I thought it was going to take. But hopefully seeing these 2 examples kind of worked out in in very very detailed way will help you kind of understand the logic that you need to take when doing these non-standard conversions, because doing these non-standard conversions is really useful and really needed for for present worth comparisons, for annual cash flow, as well as setting up equations for like rate of return and all the other stuff that we're going to be doing in the later on in the semester as well. Okay, so hopefully this was useful. If you still have questions about non-standard conversions or anything that we covered, please don't hesitate to reach out. Remember, like I said, I'm here to help you guys, and so you can come in office hours, you can send me an email, and I always try to get back to you as soon as I can. Okay, so best of luck studying, and I'll see you guys in class.